Hi everyone, in the previous videos we saw how can we calculate the error with respect to each wave in the last layer. But now we will need to calculate this error, this derivative, for the rest of the layers. So to simplify the calculations the new error must do, we will denote delta in position I and in the layer L as the error signal in an error. Okay, so this value will be associated to each neuron, and we will define the delta as this thing. The delta will be the derivative of the error with respect to the net value of a neuron. Okay, this will be the delta, and it will be different for the last layers and the other layers. Okay, so in the last layer it will be very simple because we have only two functions to apply it. So to calculate this value it will be only this, the derivative of the error with respect to the out in position LG multiplied by the derivative of the activation function with respect to the net value of the neuron. So if we want to visualize it, we want to calculate the derivative with respect to this value, so we go in this direction. Okay, this is why the backpropagation goes in the opposite direction of the feed forward. The backpropagation goes backwards and the other goes forward. That is the feed forward, and this is why this algorithm is called backpropagation and is based on the chain rule of the calculus. So now if we use this new notation, we can simplify how we can calculate the derivative of the weight, and it will be the error signal, okay, in position L multiplied by the here we put L plus 1 and multiply by the net value, the out value of the previous layer. That in this case it will be this if we want to calculate this derivative. So it will be here G and here the layer. Yes. So this will be the general formula, and we can apply this formula to every layer, but the way we calculate this value will be different for each layer. Okay, why I put this value? Because the delta here will be this, and this will be the derivative will be the out value of x in position I layer L, and we have seen this in the previous video. Okay, also in the previous video we didn't see how to calculate the derivative of the error with a certain bias. So if we want to apply the chain rule to the bias, we will see that it will be the same as this. Okay, so I will put it here. Okay, so now here we'll have a different thing that will be the derivative with respect to the bias. So here it will be the same calculations, the derivative of the error multiplied by the derivative of the activation function, but also this will be the delta. But here it will be different because the function g or f, whatever you want, it was the sum of a wave multiplied by the neuron, and we add the bias. So if we want to do the derivative of the bias, if this is the variable and these are constant, this will be 0, and the derivative of the variable will be 1. So this will be a 1. So the derivative of the error with respect to the bias will be delta G in position L. So this will be the formula to know the bias. So with the error signal, to conclude, the error signal is really helpful because we can simplify all the calculations with just only one term in the bias and only two terms in the out. So in the next following videos we will see deeply how we can calculate this error signal in the rest of the layers, because in this layer we see that it was the derivative of the error and the derivative of this activation function. So see you in the next video, and hope you understand the backpropagation.